Oh yeah, that's right. You were just talking about how easy it was.
Yes, unit conversions. Now, the first thing we're going to write right here is King Henry died drinking what? Chocolate milk. King Henry died drinking chocolate milk. And that's the basic. King Henry died, meters, liters, grams, drinking chocolate milk. Now that takes care of the smaller values, these right here. The deci, centi, milli, these right here. Okay, now these micro, nano, pico, okay, we don't get into those too much, but your sciences do. I'm going to stick with King Henry died drinking chocolate milk. Because once you get past those, because here is the first three right here. Deca, let's see. This is milli. This is centi. This is deci. This is deca. This is hecto. And this is kilo.
Oh my God.
What is it?
They couldn't read the L. They thought it was an I.
Yeah, I thought it was like an iron.
Meters, liters, grams. I said meters, liters, and grams.
Well, I was trying to write.
Oh, well, no excuses. All right. So that takes care of this, this, and this. So King Henry died drinking chocolate milk takes care of these right here. Okay? So how do you use King Henry died drinking chocolate milk? Well, I'm going to show you. I'm going to give you 2 or 3 examples. Very simple. I'll put 2 or 3 of these on the test because these are standardized test questions. So let's move to King Henry died drinking chocolate milk. Meters, liters, grams, drinking chocolate milk. All right, so let's say, and I'm going to put kilo, hecto, deca, deci, centi, and milli. And a lot of people say, well, that's so elementary. If it ain't broke, don't fix it. It's the best way to do metric conversion. So let's say I want to turn in 1 meter into blank millimeters. So we start right here because it says meter. And then we move 1, 2, 3. So we move our decimal 1, 2, 3. So 1 meter is equal to 1,000 millimeters. So now let's do.
Man, I forgot how easy these were.
This is very easy. Let's do 4,000 centigrams. Or CG. Centigrams equals blank kilograms. So that means we got to start with centigrams, which is here. 1, 2, 3, 4, 5. So 4,000 decimals right here. 1, 2, 3, 4, 5. So 4,000 centigrams is equal to 0.04 kilograms. Very, very simple. It's a whole lot easier to change metrics than it is to change Standard. Standard, you have to use unit conversions.
Well, I haven't, like, I never understood why the U.S. was the only country that used standard conversions when the entire world is using this. Like, why would it be so hard for
Because
us to
of
use it?
one rule. People do not like change. And that's why.
It would not be that hard to change it,
I know.
though. It's ridiculous.
Well, I'm going to tell you a little story. When I was in elementary school, there was a big push, and they said, all the teachers would tell you, in each grade I was in, you're going to have to use this in the future. You're going to have to use this in the future. And I've yet to have to use decimals and decigram. What I mean, in other words, everything in the United States has 2 units of measurement on the label. Standard and what?
Metric.
Metric. I doubt very seriously that you're ever going to see the United States go to metric 100%.
I think it's ridiculous.
Well,
Even, like, science uses metrics.
I know.
It's, like, stupid.
But to go show you, that was in the 70s, okay, when I was in elementary school. And then when I got to junior high and high school, it was like, nah, we're not going to change. So they quit teaching. So all through junior high and high school, everything I did was pretty much in standard.
We learned it in science, and that was the only place I really
See?
taught about it.
See, that's it. I mean, they don't even teach it. So they teach it like I'm going over it right now, but that's it. They don't sit there and tell, like they used to tell us, you're going to have to learn it because the United States is going to convert. Well, we never did. I guess you could call United States redneck as far as metric system, because we still do the standard. So, and that's how you change it. Now, when you're talking about the other 3, let's go back to you have to use a little bit more, and I'll get to see if they ask, because they're probably going to ask. So let me get there, and I'm going to hit these right here. You have to multiply. See, let me just show you something right here. Somebody tell me what the difference is right here between here. Hold on. Between here, here, and here. What's the difference? What's the pattern?
It just goes up 1.
Just goes by 1, right? So that's why you can do the jumps. But when you get here, what's the difference between here and here?
3.
3 and what? 3. 3, 3, and 3. So that's where the thousands come in. Because how many zeros are in 1,000? How many zeros are in 1,000? 3. So each one of these,
Oh, I got it.
you're going to have to multiply by what? You're going to have to multiply by 1,000 to get the 3 zeros in. So that's where the King Henry dies. It stops with kilo and milli, because kilo and milli is just a place of what? 1. Where these are places of 3. Make that note in your notes. And if you have to, let's do this. Let me do this. Let me erase this. If my pen would work. Okay, I can't erase that. Let me just see if I can do this. Nope, it's not going to let me. So I'm going to go down here and rewrite it. So I'm going to write King Henry died, meters, liters, grams, drinking chocolate milk. And I'm over here, you've got micro, nano, and pico. Micro, nano, and pico. And then over here, you've got mega, giga, and what? Tera. And I'm just going to put 1,000, 1,000, and 1,000. I'm going to put that above each one of these 3, because when you jump to these, you're not going to just move 1, you're going to move what? 3 places. So it's kind of like 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So when you jump from here to here, you got to go 1, 2, 3, 1, 2, 3, 1, 2, 3. Got it? And when you jump from here, 1, 2, 3, 1, 2, 3, 1, 2, 3. You got to count instead of 1. You got to count 1, 2, 3, 1, 2, 3, 1, 2, 3. Now we'll get to that in just a second when they give us a problem. All right, do that one. Convert 2759 centimeters to meters. This is the way you'll see it on a test. They'll say 2,759 centimeters is equal to blank meters. King Henry died, meters, liters, grams, drinking chocolate milk. That's mine. I had to turn it off. That's what I need to do. I need to give sample bags to all my students. Right.
Did you say meters?
Final grades. That's what I need to do.
What?
Boy, that would send a letter to my department head.
Did you say meters?
Meters, liters, yeah.
It's meters. Can I tell you the answer, or you want me to wait?
No, we're gonna do it in just a second.
Alright.
I don't want you to excel, Mr. B.
I know. It's
Remember,
okay.
I want you to be down and out. I want you to be in the ditch.
Alright.
If you excel, then you might be positive and might want to better yourself.
Yeah, probably.
Yeah, probably. All right. So where is the decimal right now? It's right there, right? So let's take our handy dandy. We want to go from centimeters to what? Uno, dos. Uno, dos. 27.59. Mr. B, did you get 27.59?
Yep.
You are a winner, sir.
Thank you.
Can you go ahead and repeat this one more?
So you can feel good about yourself?
Yeah. That last unit killed me.
There we go. Now, they're doing it by unit conversions, and that's fine, but I can guarantee you, if you talk to 10 math teachers, 9 of them are going to say King Henry died drinking chocolate milk for the basics, because it's a whole lot easier.
Oh, dang. This next one's hard.
Yeah, exactly. A marathon running race is about 26.2 miles. Now, this is a unit conversion. They're going to have to give you, there we go. They have to give you this. Now, on a test, when you're going from standard to metric or metric to standard, what do they have to give you? They have to give you a conversion. So here it is. So what you're going to do, what's the first, for unit conversion, what did Hubert tell you is the first thing to do with a unit conversion?
Put it in a fraction.
Make the number into a fraction. So 26.2 miles over 1. Why over 1? Because they don't give you a per. They don't say 26 miles per hour. They say 26 miles. So I don't have a per, so I just put it over 1. So that means what goes on the bottom? Miles. Why? Because you want the miles to what? Cancel. And here is the conversion. 1 mile equals what?
1.6093
kilometers. So now, what cancels? So somebody take, it's going to be 26.2 times 1.6093. What do you get?
Bases do you want me to round to?
Just give me the whole, just give me.
42.16366.
That's good. 42 miles. Yep. I mean, 42 kilometers. Thank you. Kilometers.
That wasn't so bad.
See, unit conversions are not bad if you start them off what? Correctly. If you just try to say 26.2 miles and you sit there and stare at 26.2 miles, it's never going to, you have to put it over 1. And that tells you what to put on the bottom.
That's how I am when I'm watching like Shark Week and stuff. They're using kilometers because
Yeah.
most of that stuff is filmed in like Britain and
Yep.
Australia and stuff like that. And I'm
Change
like,
it over.
How many kilometers is that? How many miles is that?
Yep.
I can feel
42.2 kilometers. Okay, a Fahrenheit scale commonly used in the United States is defined so water freezes at 32 degrees Fahrenheit and boils at 212. The rest of the world uses Celsius. That says Fahrenheit scale commonly used in the redneck United States is defined so water. The rest of the world, I love that. But I'm pepper and chocolate. I've never colored inside the lines. Which places the freezing point of water at 0 degrees Celsius and boiling point at 100 degrees. Now, should you write down this information?
Yeah.
Hell to the yeah, because these are 4 standardized test questions right here. Now, although I do not coach and teach to standardized test questions, I know for certain that at least 3 or 4 of y'all will have to take a standardized test in the future, whether it be employment, entrance into another school, or entry into, a program, whether it be nursing or whatever. So there's 4 test questions right there. What is the boiling point of water in Fahrenheit? What is the boiling point of water in Celsius? What is the freezing point of water in blah, 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 blah? Okay? Now, what they're fixing to do is they're fixing to give you a formula probably, and that formula is the conversion formula for Fahrenheit to Celsius and Celsius to Fahrenheit. It's based on these 2, based on 2 of these numbers. Okay, they're not going to do it yet. Write this down. In science, we use Kelvin. Kelvin is when you get extremely high or extremely low. Okay? Which is same as the Celsius scale, except for its 0 point, which corresponds to negative 273 degrees Celsius. A temperature of 0 K is known as absolute zero. I bet they're going to ask us what 273 Celsius is in Fahrenheit. I bet. Oh well. Because it is coldest possible temperature, the degree symbol is not used on the Kelvin scale. Now, what do you need to write down here? 3 things. Well,
Kelvin, absolute 0
Mhm.
equals negative 273.
Absolute 0 is equal to negative 273.15 degrees Celsius, which is 1 Kelvin. I'm sorry, not 1 Kelvin. That means Kelvin.
It's 0, right?
Yeah, 0 Kelvin. I'm sorry. 0 Kelvin is known as absolute 0, which is negative 273.15 degrees Celsius. They've got to be fixing to tell us the conversions, but anyway, there we go. 212 degrees, 100, and 373 degrees Kelvin. So this is a good picture to take, or good to put in your, this is great to put in your notes.
It gives you the Fahrenheit too for Kelvin.
Mm-hmm.
And
Very good. 212, 100, and 373. Now, why do we use Kelvin? Because once you get into extreme temperatures, it's easier just to use what? Kelvin. That's why when you're talking about the heat of the sun and all that stuff, they usually use Kelvin. Or joules. Sometimes they use joules.
That's what we do in an or bio.
What's that? My phone went up. Okay. So hopefully you got that written down. That's a very good graphic right there. Can't beat that. So at negative 500 degrees, you got absolute zero. Think about that. Only place around here that gets negative 500 degrees is Greenville, WYFF. All right. That's when we're all about to die, when they tell us that we're all about to die. Wait a minute. AOC says we're going to die in 12 years. So she got on the wine bottle last night. Did y'all see that recording, her video?
Who?
AOC.
No.
Oh my gosh, I believe she was a little bit tipsy. She started going into how we're all going to die in 12 years. That girl's crazy.
Is that the one that you were sharing on Facebook?
I guess. She's crazy. She's freaking crazy. Here we go. I told you, didn't I tell you? There's the information you need to write down. I would make a card if I was you. There is your 4 formulas for Celsius, Fahrenheit, and Kelvin. So if I was you, I would write those 4 down because basically it's plug and what?
Chug.
Now, I would also highlight this because you might see that in some other applications. Instead of 1.8, you may see 9/5. Okay? So you could rewrite, this is 9/5 C plus 32, and this is 5/9 times F minus 32 times F minus 32. 5/9 times F minus 32. But you might see that 9/5 in some form instead of 1.8. And how did I get 5/9? Well, this is 9/5 on the bottom. How do I get that up top? Change it to 5/9. That's how. So those are your 4 formulas. And the good thing about these 4 formulas is they don't ask you to do anything except for plug and what? Plug and chug. So unless you're not paying attention or you don't have the formulas in front of you, you should get these questions right no matter what. In fact, I'm going to erase this. And
So basically, you can't go straight from Kelvin to Fahrenheit. You have to
transfer it, yeah.
And then go to Kelvin.
You have to transfer it, yeah. So I'm going to go to the handy dandy snip and moist. And I'm going to, wait a minute. There we go. And I'm going to snip those out because I know the next question is going to have to do with these 4. So there we go. Save, capture, and all right. So the next question says, average human body temperature is 98.6. What is it in Celsius and Kelvin? I'm going to snip that out and put it on the whiteboard. So go ahead and write it down while I snip it out. And save as capture 2. And white screen. And bring in. I'm sorry, I'm so dinosaur. I'm sorry. I should have posters in here. There's your question. And bring in the formulas. Now, If you can't do this, then you're a failure. No, I'm just kidding. So, what are we going to do first? Well, it says Celsius. So I need to go from Fahrenheit to what?
Celsius.
So I need to use this one. So I'm going to take my handy-dandy pen, and I'm going to write Celsius is equal to F minus 32 over
Hubert.
1.8.
Our board is frozen. Like, we can't see what you're writing.
Oh, this gets so old. And it's always easily. Always. I mean, I'm talking about two semesters ago. The only one that would freeze up would be easily. All right, I'm gonna send a present screen again. See if it comes through. Okay, Miss Riddle, I want you to hang up, and I'm going to add y'all back, okay?
Okay.
Now see if it comes up. It might take a couple of seconds after you.
We see it now, yeah.
Okay. All right. I'm also going to rewrite this formula in terms of 9/5. Was it 9/5? Yeah, 9/5. So C is equal to F minus 32 over 9/5. But when you divide by a fraction, you multiply by the what? Reciprocal, Hubert. That's right, class. F minus 32. So you might see it written like this. Has anybody ever seen it written like that?
No.
Okay, well both of these are the same thing. 5/9 times F minus 32 and F minus 32 over 1/8. The main thing is, what are we going to plug in?
This is 98.6.
So C is equal to 98.6 minus 32 over 1.8, and C is equal to 5/9. I hate this phone. They're putting too much stuff on phones. Okay, I'm sorry. 98.6 minus 32. And here, what's 98.6 minus 32? 66.6. Dang old 3 6s, we're all going to die in 12 years. Some of y'all don't even know what 3 6s mean. 5 over 9 times 66.6 over 1. And both of these, what are you going to get? 77? 37 degrees Celsius.
So we're going to get the same answer either way.
Yeah.
So if we're more comfortable just doing the decimal, could we just...
It's whatever y'all
do
want
the
to do.
decimal?
The reason I'm showing it to you is so when you see it as a fraction on a standardized test or on a test, you won't freak out.
Okay.
37 degrees, you'll get the same answer no matter what. Now, take that 37 degrees, part 2, and which one are we going to change? We're going from Celsius to what?
Kelvin.
So we need to do Kelvin is equal to C plus 273.15, and K is equal to 37 plus 273.15, which will give us 300?
310.15.
310. 310.15. And you feel good about yourself. Now that's a good test question. Why is that a good test question? Because it's got 2 parts to it, and it covers, 2 for 1. You kill 2 birds with 1 stone there. And like I say, any of these questions that have to do with Fahrenheit, Celsius, Kelvin, or Celsius, it's going to be plug and chug. No unit conversions, just plug and chug. So let's see what they get. let's go back to the question so we can make sure we feel good about ourselves. $37 degrees, is that what we got?
Yep.
And 310.15. So that's a good test question. So make a note on that one. There we go. Energy is what matter moves or heats. International metric unit is, I don't know. Energy is what makes matter move or heat up. Okay, thank you. International metric unit is the joule. Okay, this is where you're going to use unit conversions, especially if you're in calculus, because we did this a lot in calculus. Power is the rate at which energy is used. International metric unit is the watt. 1 watt is 1 joule per second. So I would write down 1 watt. Now I'm probably not going to ask you a lot of test questions on joules and watts. Why? Because you're in 103. What's the chances of you going into physics or chemistry? Very, very little. Okay? So I'm not going to spend a lot of time on joules and watts. But I'm going to show you how to do it. It's going to be a unit conversion where you cancel them. A kilowatt hour is a unit of energy. 1 kilowatt hour equals 3.6 million joules. 1 kilowatt hour equals 3.6 million joules. A utility company charges 15 cents per kilowatt hour of electricity. Boom. We're not going to put it over 1. What are we going to do? We're going to put 15 cents per what?
Kilowatt.
Per 1 kilowatt hour. So you're going to start this problem with 15 cents or $0.15 or 15 cents over 1 kilowatt what?
Hour.
Okay, you could say kilowatt per hour, but we're not going to go that in depth. How much does it cost to keep a 100 watt light bulb? Okay, 100 watt light bulb on for a week. How much will you save in a year if you replace it? Okay, now, they're going to give you the information in the next step. Okay, write that down. 1 kilowatt means 1,000 what? Watts. So I'm going to put 1 kilowatt equals 1,000 what? Watts. What cancels? Oops. Now that don't cancel. Oh, Lord. Hold on. Okay, so now what do we have now? 15 cents per watt hours. You see what we got? 15 cents per watt hours. Now we don't have kilowatt hours. We have watt hours. Now let's see. What do they want? How much does it cost to keep a 100-watt light bulb. So I'm going to take and put 100 watts. Why am I putting 100 watts up here? Because what? Because I want watts to cancel. Now what does that leave? 15 cents. Cents per what? Hour. So let's see what we get. Let's go ahead and take 15 cents over 1 kilowatt hour. I'm going to just put per hour there and then times 1 kilowatt over 1,000 watts times 100 watts, that's the bulb. Oops, not 1,000. Okay. 100 watts over 1. The watts cancel. The kilowatts cancel. And now we've got cents per what? Hour. Now, what does this say?
Per week.
Okay, so we got to cancel those hours. So 24 hours is in what?
1 day.
1 day. And do they say 5 days or 7 days?
7 days.
Where does it say 7 days?
It says for a week.
Okay, now see, they're not being, they should specify the week, because some people say 5 days is a week, business week. We're going to go with 7. 7 days is equal to 1 what?
1 week.
All right, now cancel out your remaining, let's see, days cancel and hours cancel. So somebody tell me what units we have left. Cents per what?
Per week.
Per week. Wait a minute. That's going to be a lot of cents. So what do we need to do? We need to get rid of cents. How many cents are in a dollar?
100.
100 cents are in one what?
$1.
So take the cents out. Now we've got dollars per what? All right, now multiply 1 times 15 times 100 times 24 times 7. And somebody tell me what you get.
$252,000.
252,000. And somebody take 100 times 1,000. Well, that's what? 10,000 or
Yes.
100,000? 100,000. Oh my gosh, look at here. What do we do with those zeros? Oh. And then we can take $2.52 per what?
Oh. Day. No.
Per what?
Per week.
Per week. $2.52 per week. Unless we've got a decimal off.
No, you're right. They did it a different way, but it was more confusing the way they did it.
Yep. All right, write that down because that's the easiest way to do that problem. And all starts from where?
15%.
It all starts from the first fraction. That's why it's so important for you to put, you can do unit conversions all day long if you put the first part in the form of a fraction. All right, let's see what they do.
Oh my God, I made it so confusing.
100 watts, yeah, they're doing the same thing. They're just not putting everything as a fraction. And when you don't put everything as a fraction, you get confused. Yeah, they're doing it in pieces. Okay? Now, they also asked one other thing in the question. Let's see what else they asked. Hold on a second. Where's the question? There we go. How much will it save in a year? Okay, you got to do 25 watts of power. Okay, how much will it save in a year if you replace the bulb with an LED bulb that provides the same amount of light for only 25 watts of power? So you're going to have to do the whole thing over at 25 watts. So let's do that. 25 watts of power. So I'm just going to, let's just go up here and let's just change the what? Right here. Change this, right?
Yeah.
So let's change that, and I'm going to change it to blue. And we're going to erase this. Well, I hit erase. Okay, I guess we're just not, oh, I can't erase it because it's, oh, there we go. Oh, I can, oh, saved it, that's fine. All right, I'm going to mark this out in blue. And we're going to replace this with 25 watts. Somebody do the math for me. Just do all of it. Okay, I'm not going to ask you to do anything. I'm going to just ask you to do all of it. That's going to be 1 times 15 point, I'm sorry, 15, yeah. Times 25 times 24 times 7 over 100,000.
63 cents.
Well, hold on a minute.
Yeah, I got 63 cents.
Okay, I've lost the question now. And y'all are zipping. That means convulsions, so that means what time is it?
10:03.
3 minutes after.
Y'all have a reason to. Okay, we'll finish. Just remember where we're at. We'll finish this later. Yep, Monday. Y'all have a good day.
You too.
And I'll put this up. So this is, I'll put this up right now. Y'all have a good weekend.